coming next. Okay, fine-tune universe and intelligent design. This is going bigger than I thought.
But it's quite good. I can see very clear.
Okay.
Mm.
One of the reasons why we deal with this topic within the larger picture is the pervasive perception outside the world that Christianity and science conflict with one another, and in particular, modern science, new developments in cosmology and biology, for instance, the theory of evolution, scientific topics like this have rendered or discredited Christianity. So, but of course, it's a vast subject. And when Living asked me to share on this topic, I said, okay, I'll give it a try. I don't pretend to be the biggest expert on this matter, but I share whatever the Lord has taught me. But first, I need to explain what I'm up to. What is the fine-tune universe proposition? It says the conditions that allow life in the universe can occur only when certain fundamental physical constants lie within a very narrow range of values, so that with the slightest changes in these values, the universe would have developed very differently. And life as we know it, I think that's a very important phrase. Life as we know, carbon-based life, we may want to say, would not be possible. So I will do a fine-tune universe, and after that, along the way, I will mention here are some, I will say some of the fine-tuning parameters. After that, in passing, I will mention multiverse, inflationary cosmology, something about string theory, not because we are able to grasp all these very esoteric topics in science, but they crop up along the way, and then unfortunately, the first part of my talk will be a little bit technical. I hope not too technical. Then the second part, I think, will be more interesting to the average person, as I will be dealing with this thing called irreducible complexity, an idea which was developed by Michael Behe, B-H-E. I am sure there are other experts in this group who know the subject better than me, but it should be included as part of the whole perspective on understanding how the universe displays a character of fine-tuning in such a way that it triggers off questions whether we ought to go beyond the fine-tuning and ask whether somebody is doing the fine-tuning. But here, according to this proposition, the universe has a certain fundamental physical constants. What are these fundamental physical constants? If let's see, here you are. Don't worry about some of these extra numbers, but for people who do physics, you will find that we physicists deal with lots and lots of equations. Equations, certain constant numbers crop up irresistibly, you may want to say invariably, and they are constants which have been measured to long decimals, and the validity and application spread across all the various fields of physics. And so they're called universal constants, so to say. The most well-known, for example, here, the speed of light, 3 times 10 to the power 8, 300,000 kilometers per hour, something like that. Speed of light, all the Einstein theory equation will deal with here. C. G is gravitational constant, the famous Newton's gravitational constant. All the equations will have some kind of symbols like this. Planck constant deals with quantum mechanics. And so you have the charge of the electron. So the point is all these various constants, whether you deal with electromagnetism, whether you deal with theory of relativity, whether you deal with thermodynamics, they all, quantum mechanics, they all appear. And so these constants cannot change, but by themselves, they shape how the equations physicists develop unfold, you may want to say. So now, I said earlier, if there is such thing as fine-tuning, and it's called fine-tuning because these values must fall within a very narrow range. If you just go out a little bit, life as we know cannot develop in this universe. So the point is, does fine-tuning, if there's fine-tuning, should there be a fine-tuner? The moment you talk about like this in science, the physicists, the horns will go up, the ears will prick. and they think this is importing metaphysics into science. And so the ID movement, the intelligent design movement, which also talks about fine-tuning, has met very hostile reception from what I call naturalistic scientists. Naturalistic scientists are those scientists who feel that science should be restricted to what is immediately accessible through physical perception or experimentation. And they say this intelligent design, for all its alleged sophistication, is actually a new version of the old so-called new creationism that was very dominant in the 1970s. Wickham and Morris, the Genesis flood, people who argue that the universe was created 6,000 years ago, which the intelligent design people do not basically subscribe to. But it's good to stigmatize it for the naturalistic scientists, to stigmatize them so that they don't have to take them seriously. So that's the background. It's to some extent the fine-tuning argument, which alert us to these features of design in the universe, and then tickle our mind whether there's a fine-tuner, is not totally novel, so to say. That we have some predecessors. So what is most well known, as I see now, my bar has been. Let me try to see if I can move the bar away from the. I can't read the. Can. Okay. So the question whether the world exhibits signs of design, fine-tuning is not new. Way back in ancient Greece, there was this big debate between the Epicureans and the Stoics. The Epicureans say, no, the world is by chance. The Stoics say, no, there is providence and design in the world, providence in a slightly different sense. And then from then came Aristotle science, which the famous four causes: the formal cause, the material cause, the efficient cause, and the final cause. Now, these causes is strange to modern scientists because it was aged out by Galileo, who pioneered mechanical science and seemed to be more productive than this ancient Aristotelian science. So to talk about causation, to talk about the final causation of teleology and purpose was strange to the modern science since 200 years ago. But there was a revival of this kind of argument by the famous person called William Paley, with whom we associate with the famous watchmaker argument. This is the precursor to the modern discussion on fine-tuning. For example, he says, if we found a watch on a heath, a sandy patch, we would assume that it has some designer, because when you analyze the watch, you find all the intricate parts and the ability to tell times. So with this science of intelligence and purpose, it must have a designer. And so by analogy, we would say the same of nature. And to him, with the limited development of science in those days, he said, you look at nature, it displays purpose, birds have wings to fly, regularity was observed in the orbits of the planet around the sun. That was already after Copernicus and Tycho Brahe. And so as we will watch, the attributes of purpose and regularity are suggestive of design. So likewise, looking at the world, with all the exhibition of design, they could be a designer. So what is the more argumentative kind of presentation of his position? Paley's argument stated formally, from a complex object of many parts, containing the qualities of regularity and purpose, we may infer that it was designed. The world and its contents are complex and of many parts, containing the qualities of regularity and purpose. We may infer that the world was designed. Conclusion, the world has a designer, so to say. Okay. So that was the earlier precursor. But in the 20th century, you have Christians who, after the Monkey trial, seem to have retreated from public life, make a comeback to the scientific guild with its own, you may say, attempt to remind science that they need to consider beyond all the empirical examination, that there is limitation of science, and perhaps there is a higher reality or designer behind the design world that we see. So in 1961 onwards, you have the new creationism, the young earth flat geology people. I'm going through this very quickly, so this as I set the stage for my discussion on fine-tuning. Texton wrote a book with someone else wrote a book, Mystery of Life Origin, which argues that whatever biological science have tried to do, including the experiment by Oparin and friend in Chicago, the origin of life has never been explained adequately by science till today, I may want to say. But of course, there's a reaction. Richard Dawkins wrote in 1986, The Blind Watchmaker. In other words, there's no design. Nature randomly produce what you may think are apparent design, which has misled the theist, so to say. Then 1996 is Behe, who wrote about Darwin's black box. In science, a black box is something a kind of system that we do not know, we have not deciphered. Something, it's not your aeroplane black box. This black box is just this unidentified system whose inner workings we have not identified. Dembski, Cambridge graduate from his PhD thesis, published about the design inference, which tried to argue through very rigorous mathematical calculations and philosophical discussion that one may not only talk about design, but one can detect, or rather the word infer design. The word inference, I think, is a very deliberate choice chosen when we talk about scientific discussion. More of that later. Meyer himself wrote about the signature of the cell to argue that the modern understanding of the intricacy of the cell should alert us to design as well. And most recently, he wrote this book called the Return of the God Hypothesis. So I thought it'd be good for you to take note of this landmark discussion. Now, in terms of design, we talk about intelligent design. How do you know there is design? Well, you look at whatever phenomenon, natural phenomenon, and what we want to find out some of the characteristics that will alert us to the possibility of design. So if that's what SETI Search for Extraterrestrial Intelligence began more than 50 years ago, where we try to send some radio signal into outer space and hope, based on what we have programmed to be sent over up into outer space, if they were to be intelligent life out there, having received the signal, they can infer that this signal coming from this small little blue dot called Earth actually do have intelligent creatures sending out the signal. Now, this idea was exploited by the movie Contact movie. I don't know whether you have watched this or not, where astronomers receive this strange signal 101010, the beats and pulses. This is and then they look at this. What is this? People will say, but somehow the smart fellows, they say, "Hey, look at this. The sequence actually manifest a description of the prime numbers from 2 to 101." Wow, who could set up this sequence in such a way that they will tell you about the prime numbers? So the conclusion is it can only come from an intelligent source. So this is an example from a movie, albeit a movie, but it reflects a reality, how one may infer intelligent design based on characteristics of what we are examining. So there's a premise here when we talk about detection of scientific of intelligent design. It says here, from artifacts with specific complexity. I will have to explain what is specific complexity towards the end of the talk. We infer human intelligence and design. So I will need to spell this out later. Or we say from certain features of the world, we infer an intelligent cause responsible for these features. Now, this may sound like a big mouthful, but actually, code breakers. To us, when we receive them, not knowing it, we just think it's just a jumbled up signal or communication. But cryptographer, by training, by instinct, know how to decipher them into meaningful communication. Same thing with forensics. They go to a scene, some forensics go to this place, and the insurance company say, can you check and see what the fire is about? They look around, they look from certain evidence, and they can infer that this is not a natural fire, but it was started by somebody in order to claim insurance. So this is an ongoing practice by professionals, where when you talk about detection, it doesn't mean it has to be in the lab, but based on certain character and patterns of meaning, one can infer. Infer means to go backward to determine what could be the probable cause of what we are seeing in front of us. So this is building up the case. Now, I've said about intelligent design, and for today, I decided to basically focus on a narrow band on the recent development in cosmology, because if we are talking about universal constant, we will have to put it in the context. Now, I don't want to go through all this. It's just to show you that one of the series of stimulation for the emergence of discussion on design was that realization in the last century that the universe has a beginning, and that was called the Big Bang. Okay, so it began, for example, okay, let me just say, through all the ages, scientists and most intellectuals all prefer an eternal universe. Even Einstein didn't want a universe with a beginning. Yes, he tried to shift his equation so as to avoid the possibility that the universe is expanding, because if it is expanding, then it must have expanded from some time ago, from a beginning point, which may sound suspiciously like the Christian teaching of creation. So let's say with Einstein, his theory suggests that the universe could be expanding, which he's trying to avoid. But a Catholic priest, Lemaitre, tried to convince Einstein that he got it wrong. And then with the development of the 200-inch telescope in Mount Palomar, and through reading of the stars, the redshift, meaning when you look at the spectrum of the star, there is an interesting shift towards to the red side of the spectrum, and that suggests that the universe, the stars are receding from us. And the further they're from us, the faster they are receding from us. So this suggests that the universe seems to represent a kind of explosion. So in that case, the universe could have a beginning. Of course, lots of scientists try to avoid that. The famous, world-famous Fred Hoyle, Hoyle, trying to avoid that by developing a theory called the steady-state theory, so to say. And but then in 1963, on this side here, two Princeton astrophysicists, along with, in 1964, Penzias and Robert Wilson, using radio telescope, discover there is a cosmic microwave background radiation. And from this kind of background noise, as you measure the night sky, the only conclusion was that this is a remnant of a kind of ancient primeval explosion of the universe long ago. And that was considered to be conclusive evidence that the universe is beginning. So this is just a set of context. So this is the current kind of picture of our understanding of the universe. There was an explosion, the Big Bang, so to say, for a very, very mini microsecond. And after that, for a while, the universe was only just energy and hot gases. There was no star, and until about up to 300,000 years, you have the last of the cosmic microwave background scattering. So just take some figures, and then 200 million years later, after the first bang, the stars began to form, and the galaxy. So the universe is now determined to be about 13.7 billion years ago. And then, and interestingly, there are some problem with the Big Bang, meaning that how come the universe seems to be expanding faster than what we can attribute based on what we thought could be the observable matter of the universe. So in order to explain why the universe is expanding faster, astronomers postulate this thing called dark energy, which comprises 72.4% of the universe. The observable matter is only 4.6%. And then based on observation how galaxies could form and spinning faster, there could be dark matter, 23%. So the observable universe is actually very small. By the way, dark energy actually means we don't know what it is. But neither is it pure theory. It is measurements that force the astronomer, astrophysicists to postulate something there that is responsible for what we observe in the current expanding universe. So this is the background. So with all this going on, as the physicists study the nature around us, in all the calculations, they found that alongside with all the constants that I was talking about earlier, there are values that must be maintained in such precise manner that if these universal constants that are the result of interaction of the physical laws, the parameters for the physics calculation must be just right. Anything slightly out means no life is possible already. So this is called fine tuning, based on based on the calculations, our observation and calculations of the universe. The constants must be exact, or practically speaking, beyond which not life is possible. So we come up with an updating of what was, we may say, Paley's argument earlier. The fine-tuning of the universe either happened by chance, by necessity, or intelligent design. The fine-tuning of the universe did not happen by chance or necessity, based on the least probability that we think it could have happened if it were naturally the case. Therefore, the fine-tuning of the universe happened by intelligent design. Wow, can you imagine all the atheistic scientists, all the flags are out already. So what are these universal constants? They are, as I keep going back to that, there are two kinds of, just as an example, Martin Rees, well known for his study of galactic formation, wrote a book called Six Numbers, something like that. 6 numbers that describe the universe. Don't worry about all these other, some of the very technical things. Some of you have no idea what it's all about, but just get the general picture here. So he mentioned these 6 numbers. N is the strength of the electrical forces holding atoms together, and then they must be determined to the precision of 10 to the power of 36, 1 over 10 to the power of 36. Now we put numbers, 10 to the power, we just put 0 only, 10 to the power 1, 10 to the power 2, 10 to the power 10, 10 to the power 100. I think most of us have we don't realize that once you increase the power beyond a certain point, we can't actually imagine how big a number it is already. So the word N on electrical force, epsilon, determine how firmly atomic nuclei, the atom nuclei bind to one another, which will determine whether there could be formation of carbon. As I've said, life as we know is carbon-based. The carbon, hydrocarbon, the benzene ring, if you do biochemistry. Omega determine whether the mass of the universe. So anyway, he wrote the whole book and showed that they all requires very fine values. All these physical constants that haunt all the physicists, you may want to say. So I put it a bit more later. Now in physics, we talk about the four forces, fundamental forces: strong nuclear force, electric magnetism force, weak nuclear force, gravitational force, in decreasing order of strength. So, for example, the gravitational force constant, if it changes by the 1 over 10 to the power of 34, the stars will burn up too quickly. If the stars have to last longer in order to allow the planets, I guess, to develop, hopefully, to arrive at a condition that allows for the emergence of life, so to say. Now, I just want to put down here some of this. This is a whole list of fine-tuning parameters. Number 5, I just want to say the cosmological constant, lambda. That was the one that troubled Einstein a lot, that he tries to shift it a bit to prevent the suggestion that the universe is expanding. And whether the universe expands or collapses, the different models that the universe could either expand or collapse depending on how you deal with this cosmological constant. The universe, as we know now, is expanding faster. So the universe can either expand indefinitely depending on how matter that we have, how space, which way space is curved, or some who want so if it expands continuously, it could also even trace backwards, collapse backwards. So the so if the universe had universal cosmological constant has shifted by as much as 10 to the power of 120, instead of the universe expanding, the universe could collapse, and we will die a heat death, so to say, as the universe collapse. So there will be no life possible. Now, interestingly, the Roger Penrose, one of the most outstanding physicists that we know today, he tries to do some calculations. These are smart people whose calculations are, I'll be honest, huh? He did some interesting calculation about the estimated number of atoms in the universe, the number of entropic states that will be available. And then he says, for the universe to expand as we can observe it now, what was the condition that enabled to ensure that the universe would, the Big Bang is possible? And he calculated that should there be a variance, because in other words, for the physicists, for the beginning of the universe must be what they call a low entropy, highly ordered state. And so if the number is changed by 1 over 10 to the power 10 to the power 123, there would have been no Big Bang, the world that we see, and along with Big Bang and subsequent development that allows life to emerge. So now, to put things in perspective, I don't know how to go back with this screen sharing. Sorry, yeah. Yeah. Oh, I used all the big numbers at 10 to the power of 10 to the power 123, for example. Here are some of the numbers I gathered from some people who have done all the homework. The universe is claimed to be 13.3 billion years old, which is only 10 to the power of 17 seconds. How many atoms are there in the universe? 10 to the power 80. These are estimates, okay? These are estimates, clever guesstimates, so to say. And then, if the cosmological constant up here, lambda, changed by 1 over 10 to the power 120, it will have life would not emerge. Can you imagine? Any alteration of the cosmological constant by 10 to the power 120, which is way bigger than the number of atoms in the universe. I think if you go back, you have to try to grasp what are all these 10 to the power, 10 to the power. No, it's not just number. No, these are magnitude that are way beyond our actually finite comprehension, so to say. Exceedingly big, you may want to say. So the precision, in other words, has to be exceedingly fine. Likewise, when Penrose talks about in order to attain the possibility of low entropy for the universe Big Bang to occur, you have to have this level of 10 to the power 123, 1 over this. What this chart says quickly, really, is that should there have been the slightest variance in the condition of the universe determined by this universal constant, there would have been no Big Bang, there would have been no formation of the galaxy, there would have been no, and the planets, there will be no life as we know. And actually beyond that, much earlier will be formation of heavier elements and so on. So I'm just building up my case now. So let me go again. Now, let me just summarize what I've said in the last few charts. The values of the universal constants controlling the interrelationship among space, time, and energy in the universe must fall within a very narrow, close range in order to allow for any life to develop. But the possible values that these universal constants could have would have disallowed any form from developing are astronomically higher. Therefore, the odds against an entropic condition, a condition where human life can happen, occurring are astronomically high, making any life form of the universal condition allowing of life form exceedingly improbable. This makes it highly unlikely that the condition of life in the universe occur by pure chance, which begs the question for an explanation, physical or metaphysical. So this is to say, if one constant already must not deviate by the slightest amount, what more ensemble, a collection of all improbable changes that must not be allowed to happen, but they happen in such a way that life emerge. So it begs the question for an begs the need for an explanation. If we say by chance, this extremely improbable development would not have happened, but it happens, we must ask whether there is a higher drive behind it, so to say. Now, that was called those were the constants dealing with the cosmology. That was what you call cosmic fine-tuning. Now, the other aspect will be more understandable to us, called the regional fine-tuning. Regional fine-tuning will deal with, let's say, the solar system or local planetary condition. The person who has done a lot of work on this is Hugh Ross. Reasonable faith, HUGHROSS, okay? Now, this thing, I remember in my Form 6 days, we were talking about this, how the condition of the planets in the universe and the sun must be just nice. And then some examples given, so that if the conditions are not what we see, then we know life. So, for example, steady plate tectonics, this is livingly's specialty, with the right kind of geological interior, which allow carbon cycle and generate protective magnetic field. I got this from Hugh Ross. It's not my research, okay? I'm just taking his expertise as authentic. So if the plate tectonic is too thick, there'll be no plate tectonic. But anyway, he says this allow for, or if it's too thin, you get too much volcanic activity. So stuff like living will answer this question. So the moon rotation is very interesting. Now the Earth has to be tilted at the right angle to allow for season. If the Earth were just steady like that, it would be too hot for a long time. The climate would have been too hot and too cold. I can't imagine life emerging from that. So the moon has its part to play in stabilizing the rotation of the Earth and the tilt of the Earth, which allows for stable climate and the seasons that sustain complex life. So it has to be the right planet size for Earth, for example. If the magnetic field is too small, then the solar wind would strip away the atmosphere of the Earth. So you can't imagine life developing. These are what you call regional fine-tuning. So at the same time, the position of the Earth has to be right. Too close, like Venus, is too hot. Too far away, like Mars, you have. Now, I don't know how it works. Hugh Ross talked about racial glaciation, which will leave the surface dry and hostile to development of life. Now, Jupiter, the big planet around us, has also a purpose. It's like, because Jupiter is so much bigger, it has large, strong gravity. It expects all the comet and asteroid bombardment. Without asteroid, as what you call the dustbin collector, rubbish collector, deflecting and attracting all these additional asteroid bombardment, the Earth would be inhospitable, so to say. By the way, the position of the planet in the in the solar system, such that it's sometimes it's called the Goldilocks zone. You know the story of Goldilocks. One of the plate was too hot. Then the father's daddy bear's plate was too hot. Small one is too cold, and then the other one ngam, you know. And so Goldilocks would eat up the soup. So that's called the Goldilocks zone, the zone within the planetary system that is optimized for the development of life. Even the position of the Earth within the sun within the galaxy. You know, our local Milky Way system is like a spiral. We are at the edge. And if we were too near the center, there'll be too much of solar activity, black holes, and life cannot emerge from there. So, and at the same time, so we're safely away from the center, and we have an orbit that is similar to the orbit of the galaxy, so that we don't cross the other stars and be exposed to more solar activity, stellar activities. Okay, so these are the whole list of activity. You want, actually, I can put this on my website so that you can take your time to go through them. I just want to give you the big picture, that's all. So with all this optimum condition, we seem to work together to allow the emergence of life that we know. In other words, could it be designed, so to say? So back to the argument, for the scientists to look around, if you decide to be willing to look further beyond just trying to do some abstract measurement and see if they could be designed. So those who are convinced that they are based on this universal constants and optimum condition for regional situation of the planet, suggesting design, then the argument for intelligent design would be to say, if God acted to design the universe, we would expect the evidence of fine-tuning from the beginning of the universe. But we have evidence of fine-tuning from the beginning of the universe and from our regional planetary condition. So we have reason to think that an intelligent agent that transcends the universe, also known as God, acted to design the universe in such a way that it makes life conducive. Now, this is what the theistic scientists talk. But what about the unbeliever? Very interesting. Stephen Hawking, who seemed to toy with the idea of God's existence, but to the end of his life, finally decided that God does not exist, has this interesting description of the subject we are talking about. He says the remarkable fact is that the values of these numbers, the constants of physics, seem to have been very finely adjusted to make possible the development of life. Then he gives some examples. That's similar to what I have been talking the last 10 minutes. It seems clear that there are relatively few ranges of values for the numbers that would allow the development of any form of intelligent life. Most sets of values will give rise to universes that, although they might be very beautiful, would contain no one able to wonder at that beauty. One can take this either as evidence of a divine purpose in creation and the choice of laws of the science, or as support for the strong anthropic principle. The anthropic principle being the conditions of the universe in such a way that life is possible. So here is the testimony of Stephen Hawking, who does not believe in God. So I assume you all know who he is. So Fred Hoyle, I mentioned. Fred Hoyle was also well known for his calculation on how carbon could be formed from hydrogen and helium. From his background, in order for life to form, elements must develop from light atoms like hydrogen and then helium. And how do you get from there further combination that will give rise to carbon? All the calculations suggested difficulties, how this could ever happen at all. And until he suggested certain idea called resonance energy in terms of chemistry, how atoms have certain vibration, and through his complex calculation, he calculated what would be the exact value of the energy. And so his explanation how carbon actually could be formed, despite initial impression that it could not be possible by natural means, made him world famous, so to say. So he says, he's an atheist. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The number one calculates from the facts seem to me so overwhelming as to put this conclusion beyond question. Now, to him, somebody has monkeyed biology, but he doesn't believe in God, not the creator God that we know. He talks about some possibility of some alien seeding the earth, like your Prometheus, right? Something like that. So one can acknowledge fine-tuning that make improbable life emerging and yet still refuse to believe in the creator God that the Christian believe in. But here are their testimonies, okay? So we're left with two options based on what some theists discern to be designed within the world we observe and what others say no. So one option is there's a supernatural design intellect that has built into the universe so that the improbable happens. No, life doesn't happen so easily. We have tried to make contact with intelligent beings from outer space for 50 years already. Nothing has been happening. They can do all kinds of theological discussion on that. Huh? Alternatives, so in life may not be as common as we think, at least within our observable level. Granted, you have discovery of new planets beyond the presence of solar system, but most of them are too big, so that life is not possible. Alternative scenarios is the multiplicity of universe allowing the weak anthropic principle to work. Meaning, so the idea is the atheistic unbeliever scientists, okay, look at the universe, all kinds of fine tuning, but life is improbable. But what if this is not the only universe? But what if we have multiplicity of universe? If you have worlds upon worlds upon worlds, however improbable it is that we cannot have life emerging, if given the sample size that is large enough, infinite in size, surely there will be a lucky planet somewhere like ours where life will emerge. So this is called the multiverse hypothesis, in order to avoid the compelling argument of fine-tuning and maybe design in the universe. So these are the two scenarios. So basically, what happened is this, atheistic scientists don't like the idea of the Big Bang, because it's just creation. They don't like the idea of the fine-tuning of the universe. So what do? Let us create possible universe. How do you create possible universe? We are not gods, but we can create models of possible universe. We do equations. When you do theoretical physics, basically what you do is we form an equation about the various possible relationship between, you may say, cosmological factors, and then we put different weightages to different parameters in the equation, and then we define the initial condition. We define what is called the boundary condition, and then you do the calculation. You have certain results which you can interpret to be a possible model of the universe. That's how physicists do it, mathematical physicists. So, for example, Einstein field equations which describe general relativity, and so with this equation, you can play around with it to see under what conditions the universe may expand. It may be steady, it may be contracting, so things like that. So in other words, physicists say, let's play along with some equations that we will stick to be models of the universe. And then from some of these equations, let us adjust it a bit so that there will be not only an expanding universe, but multiple universe. That's what they're trying to do, okay? So is this a viable option? Multiple universe. I mean, it's all in science fiction, right? So what happened is they find some justification why they want to do this alternative model, because as convincing as the standard Big Bang theory that we have today, which is, I don't think there is much, it's a general consensus, but science can always be questioned based on how you reinterpret some data. So in order to avoid the standard Big Bang theory, let's have what you call inflationary cosmology. What is inflationary cosmology? Or cosmologies, the different models. I mean, physicists can just adjust the equation and you get another universe, so to say. What they say is, imagine the Big Bang at the beginning, by the early beginnings, split second, there was a tiny region at the Big Bang that suddenly expand on steroids, 10 to the power 60 times. So there was a big expansion for a short while, and then after somehow the expanding universe, this super expansion energies kind of switch off, and then after that the universe cruised along as what we see today, steadily, so to say. This was this thing called inflation, means go up. But inflationary universe was proposed by Alan Guth from MIT in 1984. There are various calculations and reasons why they want to do that. I don't need to go into it. But this is a graph which shows something like that. If you face the universe back up to 10 to the minus 43 seconds, after that, the laws that we know don't apply anymore. So this is called the Planck epoch. This is called Planck number, 10 to the minus 43. So they're saying something happened at this split second. Then for a short while, you have the grand unified theory, where you have all the three forces apart from gravity seems to be fused together because of the immense energy. So the universe expands exponentially by a factor of 10 to 43. Some put more, huh? And then, so suddenly it shoots up. If you know this chart, size of the universe and time, these are all 10 to the power of 43, 10 to the power of minus 35 seconds. It shoots up, and then after that, somehow the energy, the inflation cool down, and the universe cruises along. So this is called a inflationary Big Bang. Inflationary. It still accepts the Big Bang, but it modifies the beginning differently. Now, so that's called the inflationary universe, which explains some items in the universe, but which in complicated ways. But there are scientists who feel that, well, we don't have to worry about all these cosmological constants. But the interesting thing is, if you follow this inflationary Big Bang, you will find that there ought to be largest variation of temperature in the cosmic background. If you sometimes see this map, a kind of oval shape with all kinds of color. This is the map of the universe cosmic microwave background. It seems to be very, very evenly spread out. But if you follow the inflationary Big Bang, there ought to be a lot of variation, which is not the case. In other words, the prediction of the inflation universe does not match what we measure in current astronomy. And secondly, there ought to be gravity waves. These are mathematics beyond me also. Let me be very honest with you. And that has, in other words, the inflation cosmology faces problem in terms of measurement. But not only that, other unbelieving, Sean Carroll from Caltech, I think he debated with William Craig, and I think he's one of the best debater against William Craig, and one of the best cosmologists today in communication. And Hayward Tam must be a Chinaman. In their project, they show that if you build a inflation cosmology model, I use the word model to remind us that this is not necessarily based on measurements, but rather based on the results generated from the mathematical models that we have. So the cosmology is generating life-friendly universe, resulting from inflation is exceedingly small. 1 over 10 to the power 66 million. I don't know, I cannot describe it. The number of atoms in the universe of 10 to the power 80 is something like that just now. Now is this is, in other words, almost infinite number. And the interesting thing is, whether it's from Roger Penrose or from other cosmologists, they found that whether it's the standard Big Bang, whether it's the inflationary Big Bang, the values must be adjusted very finely so that with further calculation, we arrive at a model of the universe that allow the possibility of life emerging. In other words, even so-called inflationary universe need fine-tuning, so to say. You cannot escape. Very interesting. So there's another attempt. Okay, I think I'm going to exceed my time already. I haven't reached the intelligent, the other irreducible complexity. So some other scholars said, let's try to combine quantum mechanics and Einstein general theory of relativity. What happened is, Einstein theory deals with the cosmos as a whole. Quantum mechanics deals with a very, very, very small subatomic physics. But maybe if we can do a mathematics that combine Einstein theory and what they call quantum mechanics, we can build a model of the universe. They may help us avoid all this fine-tuning of the universe. So what happened is, if you know there's this Einstein field equation of general theory of relativity, then in quantum mechanics we have this famous my cursor Schrodinger equation. This is a Hamiltonian operator. The Schrodinger equation, quantum mechanics sees the subatomic particle as a wave function. You know, the wave function, the sinusoidal wave. And with this, if you can solve this equation, you can predict the position of the electron, so to say. And don't worry about all these squiggles. Just say that in quantum mechanics, allow us to predict the position, the distribution of the electron or the particle by h square, psi square will be the probability of the magnitude of the electron. Now, if we can do that for the quantum mechanics, we can combine that with the universe, we have a wave function of the universe at the split second at the beginning, the Planck time I said just now. It's called the Wheeler-DeWitt equation. So scientists say we can make this equation, we can make prediction, and the prediction will again try. What happens to this? Let me just put that. So what happened is, because the universe at the very beginning is described as a wave function, and if you're into quantum mechanics, until we do the measurement, the wave has infinite value, so to say, a superposition of various possibility, and that it reduces to one measurement only when you measure it. It's called the collapse of the wave function. Now, what this means is, until we do the actual measurement, the wave function, whether of the subatomic world, now whether of the universe, has infinite number of solutions, so to say, number of solutions. And if we have infinite number of solutions, what they want to say is, for these quantum mechanics people dealing with cosmology, the equation, the wave function equation of the universe allow us to interpret that for all the many solutions. I read one of the I think he's Swedish physicist, if I remember correctly, say the wave function equation allow us to read into it the possibility of many worlds. In other words, every time you have an atom moving, before in interaction it branches off. There's a famous Schrödinger cat. Until you measure the quantum wave, is the cat dead or alive when the poison goes into the room? The various possible solutions are not just mathematical solutions. The various possible solutions are actual description of the universe. In other words, there are as many universes as the mathematical solution allow us. In other words, they are parallel universes. Parallel universes which, because they follow different paths in the equation, the various parallel universes do not interact with one another. Now, Hollywood talks about multiverse, but they assume that you can go from one portal to another. I don't know how you can do that in physics, they can try to do that, but but the moment no physics will tell you how to do it, So what is happening here? In order to avoid fine-tuning of the universe, all these clever physicists say, let us build mathematical models. The mathematical models allow us to conjecture infinite number of universes. And if the infinite number of universes, however, out of this whole bunch, even improbable conditions that is necessary to allow life to emerge can be attainable. What's happening here? Can you make matter out of mathematics? Do you know what? Mathematics is all in the mind. Just because you draw an equation doesn't mean it must happen in reality. So there's the question, square root of -1, are complex number real or not? And that's a big question, when you do calculation, especially oscillations and all this and wave function, there's a square root of -1 comes out, but you have to do it. But when you go to the final solution, the complex number must disappear back into the real world number. In other words, mathematics are tools, but isn't it going too far to suggest that the mathematical equation itself create the universe? So what happened is this. Stephen Meyer, in his Return of the God hypothesis, says the laws of physics represents our description of nature. Description in themselves do not cause things to happen. Equation is equation. How does equation become matter? And Stephen Hawking himself has this very memorable phrase. What is it that breathes fire into the equations and make the universe for them to describe happen? So let me I will just skip I don't have to go down to the simple one down the line I'm going too fast. So okay, tunneling I won't bother. I just want to say all these quantum equations, cosmic equation, they do not create the universe. In physics, what happens is this: we have an observable universe. From the observable universe, we try to describe it with the right equation. In other words, equations do not create universe. Equations must describe the universe that is before us. That's what I'm trying to say. So that is a big thing I think we have to protest when the physicists play with the equation and say, here you are, here's a solution of alternative universe. So the other thing is, there is a famous theorem by Willingen, which says, very interesting, even if you talk about the inflationary cosmology, we talk about multiple universes, through some interesting mind experiment, they gave what seems to have been the conclusive and accepted proof today that regardless of whatever cosmology, whatever universe in the message that has been expanding through a reasonable time, all the universe that are expanding must have a beginning. This is a mathematical experiment, experimental proof. Okay, so in other words, now I have jumped the gun already. This thing called chaotic inflationary, which talks about the balloon, expanding faster than the. Along the way, you got little hiccups, small little balloons emerge. So little balloons that are isolated from one another, which represent separate multiverses. So the assumption is you have different multiverses eternally inflating, then there is no beginning. But the point about this famous Bode-Guth-Wellington theorem is that all universes that are expanding on the average to some degree must all have a finite past. They must all have a beginning. So I think I think I just escape string theory lah. I think I'm gone too far already. So the short story of all, whether it's string theory, I put one more point. Multiverses, string theory, landscape universes, whatever it is, from the way they develop, physicists have to acknowledge that in principle, multiverses cannot be tested because we have, in principle, no contact with parallel universes. Therefore, there's no way we can verify that this thing called parallel universes. String theory, which postulates super subatomic strings, are themselves unobservable. There is no way there's any way we can build hadron machines, maybe the size of the galaxy, maybe you can do that. Because the smaller the strings are, the higher energy is required for this thing to occur. So in principle, all these fantastic physics theory suggestions are unverifiable. In principle, they cannot be tested or refuted. In fact, one famous physicist wrote a book called Not Even Wrong. All this recent development in physics, string theory, inflation, not even wrong. So, okay, there's the big cosmos. Let's go down a bit more to something smaller. I will just go briefly to irreducible complexity. And the context of that is the theory of evolution. Okay, we know the dominance of evolution. Today, Christians, many have rejected it. It's a very beautiful theory. I think evolution theory to me is a very beautiful and comprehensive theory. To me, if you ask me, but I don't believe in it because I don't think the evidence is compelling, even though I'm not a biologist, a zoologist, or paleontologist myself. Okay, but Christians, rather than just say no evolution, what I always say, what rather than committing what they call guerrilla warfare, what alternative theory you have? What alternative framework do you have? Well, one of the reasons for evolutionary theory is dominance is that as the last line here, Darwin made it possible for one to be intellectually fulfilled atheist. The Christians say that there's design, there's intelligent design, but if you look into Darwin's theory, natural selection, adaptation, genetic mutation, successfully explain the changes of the variety of species around us. There's no need to appeal to design. That's why he called it the blind watchmaker. There's no need to appeal to God. So Francisco Ayala said in the middle here, it says here, Darwin's mechanism, natural selection, excluded God as the explanation accounting for the obvious design. Or he called it obvious design. He didn't call it apparent design. Richard Dawkins said, look at nature, you see apparent design. So this is the background where the Christians say, no, we want to argue that there is design around us at the biological level. So you have the emergence of the intelligent design movement in the 80s. So here, many of them associated with the Discovery Institute of Science and Culture. So these are a list of names: Dembski, Behe, Bradley, Craig, J.P. Moreland, Nancy Percy, whose writing seems quite popular in Malaysia, and some of these names. And then the big books like Signature of the Cell, Return of the God Hypothesis. So be aware of these things. And of course, Darwin's black box. So back to intelligent design. So the Christians say, okay, we instead of talking about fine-tuning of the universe, let's come down to this, to what we see in the world around us. Maybe there is something that there is intelligent design, not just in the cosmological constant, but in the world around us. So, so in this movement, what is intelligent design? The theory of intelligent design asserts that certain features of the universe and the living things are the best explained by an intelligent cause, not an undirected process, such as natural selection. There's a premise in this argument. Something that exhibits specific complexity points to design by an intelligent cause. I'm going to unpack all this thing now. Hopefully, sorry, you give me a bit more time. So let me just jump all this out. What is intelligent design? Now, one of the features of intelligent design is this thing called irreducible complexity. How do we know there's design? I will deal with two issues. One is the design inference filter, and then the other thing called irreducible complexity. In this claim of intelligent design, it says there exist natural systems that cannot be adequately explained in terms of undirected natural causes, and that exhibit features which in any other circumstance we would attribute to intelligence. For example, let's look at some example, the famous mousetrap, bacteria flagellum, and the human cell for sure. So these have become quite, what do you say, classical examples for the intelligent design. Let me just put one more quote, and then I'll go into the example. One can detect the past action of an intelligent cause from the presence of an information-intensive effect, even if the cause itself cannot be directly observed, since information requires an intelligent source. In other words, I would say meaningful communication or information assume that there is a mind. Let me put it, I will put it, intellect, meaningful communication and evidence of design eventually goes back to a mind. Only mind can produce meaningful information or designer, so to say. For example, in this example given, if you are sailing into the harbor, and of course the writer is Canadian, or rather in Seattle, he says that you sail across the harbor, you see a row of roses, and the roses spell like "Welcome to Victoria." Welcome to Victoria. You look at it, you don't say, oh, this is a random collection of flowers, but you say that because the phrase is communicate meaningful information, there is patterns of meaning with it. Therefore, somebody must have planted them there and arranged them there. Therefore, the flowers must have been the result of an intelligent designer. That's what it is. That's how we detect design. Now, there are other regularities in nature that happen without having to appeal to design. For example, let's deal with the various types of information or patterns of meaning. You know, crystals, they form nice regularity. Nobody designed it, but because of the molecular structure of these materials, under certain conditions, they naturally combine in such a way that they form crystals. So they are simple and specific information. They follow the laws of nature. There's a certain necessity about it without having to need human intervention. So in contrast to that, for example, you come across a pile of sand at random, or you have all the typeset in printing shop, and there's an explosion. You gather all the typesets together. You come across the word google, you know, just a bunch of letters, or your Scrabble set just fall onto the ground, and then you have a bunch of alphabets. That's what they are. They're complex. A bunch of alphabets is complex, but there's no specific information. This is by chance, in other words. But on the other hand, you come across Shakespeare, a molecular machine. They are specific, very definite, and they are complex at the same time. So the suggestion by the intelligent design movement is that if you come across any phenomenon in nature that exhibit information that is specific, all men are mortal, you know, it's like a sentence like that. It's specific and complex. So it must be the product of an intelligent mind, so to say, or design. So specific and complex information is what we are looking after. So because of that, So William Dembski came out with this, what he called explanatory filter. Let's start with a phenomena. Ask the question, is it highly probable? If it's yes, like crystallization, then you say it's by the physics laws. No need to appeal to a designer. Then the intermediate probability, I can't remember what example it is. For me, if I come across a bunch of stones, oh, I see, some of us, when we're young, we look at the clouds, oh, this looks like a human face, yeah lah, subjectively speaking. So there is some kind of meaning, but it's not by law, it's by chance, but it's not quite specific. So it's not design, it's not law, so it's chance. Okay, clouds obviously by chance lah. But if something is specific and with very small probability of appearing, then that suggests design. That's what they call the explanatory filter. Are there any examples of these things? So the one example is associated with Michael Behe, who appealed to the mousetrap. Let me give his principle and then look at his example. Detectional design via irreducible complexity, and he will try to explain what this means, is a single system composed of several well-matched interacting parts that contribute to the basic function, wherein the removal of any one part causes the system to crash, so to say, and cease the function. So there's an irreducibly complex system cannot be produced by slight successive modification of a precursor system. In other words, through the natural adaptation of the natural Darwinian process. Because any precursor to an irreducible complex system that is missing a part is by definition non-functional. What is this big statement? So he takes this example of a mousetrap. Look at the mousetrap. It's a catch, it's a hammer, it's a platform to hold things stable, you have holding bar and spring. Everybody recognizes, this mousetrap is a marvel. Whoever invented this actually deserves the Nobel Prize or something like that. We should have the annual competition on can you build a better mousetrap. But the point is, with these different parts, they are separate, but collectively they become a functioning apparatus. The interesting thing is, remove any one of these, the whole apparatus ceases to function. Without the spring, there'll be no more mousetrap. Without the hammer, there'll be no more mousetrap. So basically, this is what they call an irreducibly complex system. Why? It is a complex system, so it's complex. It's irreducible, meaning all of these cannot be missing any one part. So irreducible. It must be whole part. So this is only a few parts. Then he goes to what is called the bacteria flagellum. Now he goes to a live example. Now this bacterium from here, flagella, it has this filaments come. There's hook. This is the hook part. So to the cell. So you have this part, the filament. The filament is to help the bacteria to move around. So here, all the complex protein structure, the hold them together, that can be described the way they function like motor and ring and rod, just like our motor. You have an inner membrane like the platform, the complex motor, the rings. For any motor to move around, you have gears or rings. And so these are the various protein structure. I think if I use another foot and there's a hook here that hooks it together to the edge of the bacterium. This is another function, another same thing. Just to say that this is the whole structure that move together. What happens is, this is a filament that is a very small 40 nanometers, and it's built into the bacteria. It can rotate 100,000 rounds per minute. Can you imagine how fast this is? 100,000 miles per minute. I guess you should go to your car and say next time, rev up your car and see your tachometer, how many RPM it goes per minute. 100,000. Powerful, fast, and it can reverse suddenly. So this is a marvelous machine. So just as the mousetrap by itself cannot function if any part is missing, same thing with this simple filament of the flagellum motor, so to say. So if you think about it closely, this cannot be evolved part by part the way undirected evolution is saying. So somebody has to design it in this way. So this is an example of design. via irreducible complexity. Now, if this is the bacterial flagellum and filament, what more nowadays, with advance of science, the modern, Darwin thought the cell was just some simple as jelly, that's all. He had no idea without proper microscopic analysis of the cell. Now this one, you can ask some expert to deal with it. The various parts of the cell, DNA, RNA, what is that? Mitochondria. Each one has function. Each one has its own level of protein. Each one is manufactured and in sync with one another, so that we have the cell, not to talk about the cell combining to form organs and other bodies, plan and body structure. So the cell is an irreducibly complex molecular system. And because of that, Behe calls it Darwin's black box. We cannot fully explain how it actually works. We can see how the different parts works, but what the marvel who designed it? So it's too complex to have evolved gradually, piece by piece. No way gradual evolution can track and explain the emergence and development of the cell. So it must have been created all at once by an intelligent being. That's what it says. Okay. Now, there are other initiatives in the intelligent design movement. I don't go into it. You have I just put them in here in 3 levels, from the cosmic fine-tuning to the fossil record. This one livingly will be beautiful, because when you look at fossil records 500 million years ago, in the Cambrian age, you have a sudden explosion of whole phyla of living beings. The way the fossil record show is not as though small bits with transitional fossils emerging from one species to another, but they all suddenly emerge over a period of 10 million years. So this is called an explosion, and this contradicts all the gradualism that Darwinian evolution says. And of course, about the cell, Stephen Meyer wrote a book, Signature of the Cell, which I just showed you the picture. Now, so what I've been talking about here? What's the argument I'm trying to say? I've given you a whole series of various disjointed data, but all pointing to intelligent design and fine-tuning. What is the gist of the argument? I'm coming to the end, thankfully. So, major premise: given the features of intelligently designed objects, if an intelligent agent acted to design the universe, we might well expect the universe to exhibit finely tuned conditions of a life-friendly universe. Minor premise: we observe highly improbable conditioning of laws and physical constants and initial conditions of the universe, which makes life possible. Conclusion: meaningfully configured information or fine-tuned system originate only from a mind. That's why I use the phrase meaningfully configured information and fine-tuned systems. They always originate from a mind. Where in nature can you have that? We conclude that the intelligent mind acted out of design. Now, you put in terms of conditional probability statistic, probability of theism given fine-tuning is much more probable in the yellow than no naturalist science and naturalist process given fine-tuning, E equal FT. So basically, from all this, in all the complexities of the world, with all the evidence of fine-tuning, the Christians argue that theism, or even deism, which we don't really buy, theism provides a better explanation of cosmic fine-tuning than just basic naturalism. Now, in science, we are all is what they call work in progress we read the world based on science as we know. Even as Christian, we appeal to science, but I'm always mindful of the limitation of science and the temporary theories of science. I always tell people, if that big scientific theory, don't get too married to the scientific theory. Scientific theory will go outdated. Keep yours. I hope my elders will forgive me. I say, keep your scientific theory as mistresses, but not as wife. If you keep a science as wife, you become a widow some years later, but you can change your mistress. Okay, my elders will forgive me. But you may want to say, as far as based on what I have rushed through so far, I think as Christians, we look into the world of science. I don't think, I hope some of us are gifted, we're going to it. It can be very intimidating. But if we are willing to break the bounds that is artificially imposed by unbelievers who control the scientific view, and say and acknowledge that we ought to take a slightly different perspective on the evidence in the universe from which we infer an intelligent source. I think there is more resources for us as Christians engaging in science to lay a case for theism than the other way around. But there is no, as Pascal used to say, there's enough evidence for those who want to believe, and there's enough light for those who want to believe, and enough darkness who don't want to believe. So as much as we have presented this, it will be an ongoing battle. For example, Richard Dawkins says, I will end with these two contrasting universe visions of life in the universe. So in the universe of blind physical forces and genetic replication, some people are going to get hurt. Other people are going to get lucky, and you won't find any rhyme or reason in it, nor any justice. The universe you observe has precisely the property we should expect if there is at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. This is Richard Dawkins. He used the word apparent design, which Darwinian theory should explain away. But this is the universe. Nothing but blind, pitiless indifference. This is one vision of life in the universe. But I give you the other one. I ended a song, and there's no conspiracy. Nobody chose the song at the beginning. I chose this as the ending. This is my father's world, which was played at the beginning. This is another vision of the universe. Now, so basically, back to the final conclusion. So why we opt for a universe that is life-friendly, and that is my father's world, because we believe that behind it all, there is some justification to believe that scientific data, as we have managed to collect so far, is consistent with the theistic understanding of the universe. So the emergence of life in our universe depends on numerous factors: planetary condition, fundamental laws of physics. Then human life has emerged in our universe. A life-friendly universe such as ours is highly improbable. Almost any other set of circumstances we can think of would have been life hostile. A designer or intelligent creator would make sense of the improbable universe. Okay, I think I'll stop here, I've far exceeded my time. Thank you very much.
Thank you, Kam Weng.
I stop screen sharing.
Yeah. You far exceeded your time, because normally we within half the time we would have ended, but given that it's such a big topic, and with so many approaches to the different ones, I think it's not fair to ask you to be able to do it in half an hour.
I tell you what, so I put my slides on my website,
Yeah,
so some of you can look through it.
Can go to it and look.
Okay, I'll do that. I hope I know how to put it up on my website.
Yeah. Okay. Now, normally we would have discussion questions. So unless somebody has a very must, get it off your chest tonight kind of question, I think we should end the session so that we don't hold you back, or we can let the people go first, and then those who want to stay back and ask questions can ask questions. I think the second option might be easier. Should we end first?
Yeah.
And then we don't close the meeting, but those who want to go off, please, go off, and then the rest who want to ask questions, stay back and ask questions. Is that okay? Yeah. So
thank you all for your patience.
Yeah. Okay. So good night, and bye-bye to all those who want to leave. Please feel free to leave. Then those who want to stay on for questions and chit-chat can stay on. All right. Yeah. Wow, so many want to stay on. You got lots of questions to ask him, is it? Okay. You can unmute yourself and address your questions to to Kam Weng.
Yeah.
Okay, maybe I will kickstart the question session. On the first part, when you're talking about all this cosmology,
Mm.
of course, I've been following it also, but not as closely as you have. But what was interesting to me is that you know how science is supposed to work, right? I mean,
Yeah.
you look at a phenomena, and
Yeah.
then you present a model to explain it, and then physics would create some mathematical models, and then after you have created your model, you do experiment to test it, right?
Yeah.
So there
Yeah.
testability involved in the process of science. But what's interesting is that you know, as you are looking at different kind of like cosmologies,
Mm.
that even in the standard model, which is testable, for example, you
Yeah.
know, the inflationary universe, which is detectable through
Yeah.
redshifts,
Yeah.
through the cosmic microwave background, and not
Yeah.
only just the 3K, but also in
Yeah.
fact of the non-uniformity in
Yeah.
terms of the distribution,
Mm.
and then also the natural abundances of elements, which
Yeah. Yeah.
points a rather robust standard model
Mm.
in terms of Big Bang.
Yeah.
And because it points to a God, that people will go to the extent to find alternatives just so as to dispel it. It looks almost like for the specific purpose of, you know, eliminating the cost and intelligent designer. And then it
Yeah.
brings to mind what Paul wrote in Romans. It says, since the creation of the world, God's invisible qualities, his eternal power and divine nature, have been clearly seen, being understood from what has been made, so that people are without excuse.
Yeah.
Yeah, it looks like it's a spiritual mechanism behind that. It's raising all this, creating the confusion, and uh, you know, distracting people away from the creator and the intelligent designer. And that was the impression I have, like, you know, I mean, I knew about this, but the way you put it kind of like, you know, quickly made me think, you know, of the spiritual battle that is waged in the scientific world, right? Yeah, so that's just what I want to say lah. Yeah, yeah,
Yeah. To be fair,
yeah,
as the various scientific theory are not to
yeah,
say so compelling that one can have no choice but to accept the results. I
yeah,
mean, every model has its strengths and weaknesses.
yeah.
But from the variety of models, at least
Mm,
the standard Big Bang model,
mm,
we didn't. What I would say is that the standard Big Bang model initially was actually rejected by Einstein himself. I emphasize that through the ages, the eternal universe is what the scientists want. In fact,
mm,
some of them said we want to be relieved of the necessity of having to deal with singularities at the beginning. They want to avoid
mm,
the idea of Big Bang, you see.
mm,
So
mm,
the idea of the universe says the laws, the eternal, the scientists love that what? Invariable invariance of the law, you know. So
mm,
no need to deal with the creation, the creator. So,
mm,
but you're right. Despite that, and Einstein, despite that, eventually was persuaded. He finally said, "Yes, the universe is expanding." So
mm,
uh, the point being that it is the result of measurements,
mm,
astronomical measurements
mm.
that confirm the Big Bang. Even
Yeah,
though the Big Bang itself still has some unexplained lack of observation, but by and large it has worked. You know, just like the standard model in the particle physics. You know, they're
yeah,
incomplete theory, so to say. Even
yeah,
Einstein general theory of relativity is an incomplete theory, but it has
yeah,
worked so far. See, but
yeah,
until then, the unbeliever can say, "Oh, this is a problem. I don't have to commit my life to it."
yeah,
Much less
yeah,
to say, "I commit my life to the God behind it."
yeah, yeah. But my
So
point is this, I mean, yeah,
I ended my phrase in my podcast. I says
yeah,
the way I describe how scientists relate to science. I say two
yeah,
men look through prison bars. One see
yeah,
stars, the other see mud. One see mud, the other see stars.
yes,
I mean, we can choose how we want to interpret the data lah.
yeah, yeah. But it's not a question of, a choice or what. I mean, there should be some degree of objectivity in which you view the data, right?
Yeah,
And if I'm going to change something in the scientific theory or law, that must a
yeah,
reason for me to do that. And the
yeah,
reason should be from an observation I see that contradicts the existing law. But
yeah,
from what I see is happening now in the scientific world, at least in the atheistic scientific
yeah,
world, is that they are deliberately looking for things that doesn't exist in
yeah,
a sense that, like, if for example, when Newtonian mechanics was there, it works, right,
yeah,
until certain thing didn't work, so they had to go and look for an alternative. And the
yeah,
reason
yeah,
for that is because observation shows something doesn't work, so
yeah,
we went to relativistic mechanics, right? And
yeah,
then same like quantum theory. I mean, there's not simply you want to do
yeah, yeah,
quantum
yeah, yeah,
theory
yeah,
because
yeah, yeah.
because you see, there was kind of this
The
ultraviolet spectroscopy,
split beam theory.
yeah, yeah,
Uh,
yeah. Because they observe things that the
yeah,
standard science cannot explain, they go and exploit. But right
yeah.
now, the way science is done is not done that way. It's like,
It's mm.
it is like, hey, wait, this thing seems to point to God, so I'm going to find something that, and this thing was not observed. There's nothing there, So
Yeah,
you're just trying to
yeah.
whip out stuff here. Yeah,
Yeah, for example, the Big Bang, it
yeah,
points is a point of origin. But
yeah,
yeah, we don't like, man. Let's fiddle
yeah.
the equations, So yeah,
Correct.
not just inflationary
Yeah.
universe, but the chaotic inflammation with
Mm,
multiple universes
yeah.
that are not in contact with one another. You see in science, science must be open to testing, verification.
Yes.
But the very idea of multiverse, you say we cannot test, but they don't care because
Yeah.
we need multiplicity, infinite number of universe, so that we don't have to address the question of the
Mm,
beginning of the universe as we have
mm,
observed,
mm, mm,
as
mm,
the
mm.
data suggests. I'll put it that way.
Yeah, yeah, yeah. I just ask you, whether to some extent, it is also a reaction to the Christian approach, because sometimes I feel that we also can be unreasonable, right? And instead of looking at the things from a scientific evidential perspective, we just go and put our own color into the thing and then bulldoze our way through. So, do you think, in some sense, that these scientists are reacting to, for example, young Earth creationism,
Yeah,
okay, which is
yeah,
which is not reasonable
no,
from the data perspective, but yet Christian will push it, push it, push it, right? So,
yeah,
okay, then
yeah,
the scientist will say, you can do that, I'm going to do something similar,
yeah, yeah. The phrase used is called cherry picking.
Yeah,
You look
correct.
at the scientific enterprise, you look at the various isolated part. Oh yeah, this one confirms Christianity.
Yeah,
But actually, these are piecemeal adjustment.
yeah.
Especially the young Earth creationists, I would have to say. So they're not actually what they call developing science. They're cherry picking science to fit into a predetermined Christian mold. And that
Mm,
caused disrepute among the unbelieving practicing scientists.
yeah, yeah.
Okay,
I
any
mean,
more questions that you are dying to ask or bring into discussion? If not, I just uh, comment on just what was discussed earlier.
Uh,
This multiverses thing,
uh,
I think it sprang out of last time. Your constants and all that show that the probability will be so
yeah,
high and impossible that I
yeah,
think some Christians say that is even the total number of atoms in the universe
yeah,
it exceeds that lah. So
yeah,
with
yeah,
such
shits.
big
Yeah,
impossibility,
yeah,
how can it be what? So the multiverses thing is a escape in a sense that if there's infinite, even the number of universes is infinite. So what is the problem of, your probability of life existing exceeds that of just even the number of atoms in your, what is it? So it's an escape clause lah to try to step that. But you have to be careful of using Michael Behe's
sure.
the mousetrap is a very good illustration of irreducible complexity, but
Yeah,
the flagellum is not. because
But
the flagellum has precursors of, there was a development from a less efficient one to the more efficient one, and same thing with cells, the complex cells that we see now with nucleus and mitochondria and all that. From what we know from historical precursors to the cell, like this mitochondria were postulated quite reasonably to be bacteria which were engulfed, like the amoeba, you chomp up an external one, and then it didn't get digested, and so actually those mitochondria are entities, different from the big giant size single cell now, absorbed and so on. So with the what we have to be careful with
this is by
living systems and a mousetrap kind of
this is the counter argument by Kenneth Miller lah.
Yeah.
The intermediate parts lah.
Intermediate parts.
Yeah. So I think I would like the biologists debate it to the end, but I want to say that as it could be plausible, but I think it also is involve a lot of postulations lah. How is it I can imagine at random one bacteria was engulfed and was never digested, but what you are seeing, you mean from this one particular incident, or from there evolve all the various complex cells that we know today. Of course, this is only one part, the mitochondria, But I'll put it this way, that there is you see, whether it is evolutionary theory, whether it is intelligent design, first of all, I want to make it clear that it's not one is science, one is not science. Evolution is not science the way we talk about science, that we replicate in laboratory experiment. What this science does is we take certain observations, pattern observation, and from there what we call the famous phrase, inference to the best explanation. I wanted to cover this, but because of time shortage, I didn't want to cover it. Whether it's evolutionary science or intelligent design, we have certain observable patterns in the universe, meaningful, and then we infer different paths of development. Now, I want to say, I use an analogy. Just because there is intelligent design doesn't mean that there was no possibility of application of precursor components, I want to say. But the amazing thing is all these disjointed precursor components are somehow compiled into this irreducible system, I want to say. Now, the other thing is, I would say, I give an analogy that you can have different parts of the car motor in the workshop. They're all lying in different parts. The Kenneth Miller type would say, see, these are all various parts. But how did these various parts somehow compile in such a way? So you say there has to be a mechanic who knows how to compile the parts. The fact that we talk about intelligent design doesn't mean that the designer did not use precursor parts. I want to say it that way. But the point is, which is more probable? Or rather, based on the inference that we have and the new framework that we have, what research development do we now include? Meaning, in addition to this and all the problems faced by Darwinianism, implausible transitions, I want to say. I want to say Kenneth Miller type is also an ad hoc explanation. No less ad hoc, so to say, even for the intelligent design. So I just want to say we are on equal terms. So the larger test will be determined in terms of our explanatory power when we apply it to the larger picture of the biological system. So, but the point is, the counter challenge is newly noted, but I don't think it's conclusive.
Okay, so we are aware.
Yeah. Fair enough. The other thing, like suboptimal design and all the stuff, they are always counter arguments.
Yeah.
I think one of the thing that was the closest I feel against intelligent design, or this thing of self-assembly, that the components would naturally go find the parts that fit them. Of course, chemically is a possibility, but then when you look at from the biological perspective, I think the possibility will be reduced. Somebody did some statistics on it. and it
Yeah.
looks like the possibility of that is something an astronomically impossible number, lah, you know. It's not impossible, but it's you want to have it by chance, it's as good as improbable, lah. Yeah.
Yeah, actually, there is
That's
a
why
strong movement of mathematicians against evolution. There's a
Yeah.
strong movement now. All these mathematicians specialize in probability.
that's why
and
you
stuff.
need multiverse, is it? And you know what's their answer to you about probabilities?
Ah,
They say no matter how big your numbers are about
Yeah.
probabilities,
yeah.
the fact that we have life and earth now destroys the whole thing of probability because it has happened.
This is the strong anthropic principle, lah.
Yeah.
Just because so by virtue of how the universe has evolved, you have appeared here on Earth, and therefore you ask this question, and that settles everything.
Yeah.
I think at one level is true, another level is a very glib indifference, lah. I mean, if, for example, the illustration given, I'm blindfolded, you will roll up 20 marksmen in front of me, aim the gun and shoot at me, and after that I said, oh, I'm still alive, you know. This is highly improbable, but it does happen, you know. And that settles the question. The fact is, I'm alive shows that improbable can happen.
Yeah.
That is what you would say a very kind of a lame excuse, I would say, an indifference.
Yeah. What they are saying is that despite all the countless in numbers in the probability, the fact is that now that it has happened. So they say that probabilities cannot be used until can only be used until the event actually happened. Then it reduced to zero because no more talk about probability. It has happened.
Yeah.
Is it?
I guess at the end of the day, you can base your life on that if you want. I want to say no. I mean, nobody can stop you from doing that. If there's you have decided, that settles the question. But to me, there's not a scientific attitude, I want to say, because I want to know how the improbable happens.
Can become probable.
That's the scientific attitude.
Despite all the
or whether in the light of what improbable has happened, is it consistent with the science that we have known so far?
Yeah.
So I think the other side essentially say question closed.
Yeah. Okay, any more questions? We have far exceeded our bedtime.
What time you normally end? What time you normally end?
9:30 like that lah.
Oh, 9:30, 9:30.
It means 9, and then with questions maybe before 9:30.
Okay.
Yeah.
Yeah.
We should have broken this talk
anyway,
into 2 or 3
this is
parts.
you know, an interesting one, and we can always revisit some of the other parts which we can't cover tonight.
My fault. My apologies.
So can we call it a night?
I
think so.
So
but
thank you
we
very
definitely
much,
need to circle back and revisit this topic again. Breaking
all
them
good
down
things
into
must come to an end.
Yeah.
Okay, good night and
All
thank
right.
you.
Good night,
Good night,
everybody.
and God bless.
Good night. God bless. Bye-bye.